Chapter 4 Personal Finance Section 4.3 Saving for the Long Term Build at Nest Egg. Example: you deposit $100 to your savings account at the end of each month and suppose the account pays a monthly rate of 1% on the balance in the account. Find the balance at the end of 3 months. Solution: at the end of first month, new balance is equal to deposit, which is $100. At the end of second month, the new balance is the previous balance plus interest plus the new deposit. That's $100 plus 1% of $100 plus $100. That adds up to $201. At the end of third month, new balance is equal to previous balance plus interest plus deposit, which is equal to $201 plus 1% of the previous balance plus $100, and it's $303.01. This is what a table looks like if you do this over for 10 months. Regular deposits balance. Balance after t deposits is equal to deposit times 1 plus r to the power of t minus 1 divided by r. Example: suppose we have a savings account earning 7% APR. We deposit $20 to the account at the end of each month for 5 years. What is the account balance after 5 years? The monthly interest rate R is 7% divided by 12. The number of deposits in the total number of deposits is 5 times 12 equals to 60. The regular deposit formula gives us balance of the t deposits equal to deposit times 1 plus r to the power of t minus 1 divided by r, which is equal to $20 times 1 plus 7 hundredths divided by 12 to the power of 60 minus 1 divided by 7 hundredths divided by 12, and that's $1,431.86. The future value is $1,431.86. Determining the savings needed. Deposit needed formula. Needed deposit is equal to goal times r divided by 1 plus r to the power of t minus 1. Notice that this is a formula from the previous slides solved for monthly deposit. Example: saving for college. How much does your younger brother need to deposit each month into a savings account that pays 7 2/10% APR in order to have $10,000 when he starts college in 5 years? Solution: we want to achieve a goal of $10,000 in 5 years. The monthly interest rate R is APR divided by 12 equals to 72 thousandths divided by 12, which is 6 thousandths. The number of deposits is t equals to 5 times 12 equals to 60. The deposit needed formula gives needed deposit equals to goal times r divided by 1 plus r to the power of t minus 1. 10,000 times 6 thousandths divided by 1 plus 6 thousandths to the power of 60 minus 1, and that's $138.96. He needs to deposit $138.96 each month. Example: suppose that you'd like to retire in 40 years and you want to have a future value of $500,000 in a saving account, and suppose that your employer makes regular monthly deposits into your retirement account. If you expect an APR of 9% for your account, how much do you need your employer to deposit each month? Here goal is $500,000. T is equal to 40 times 12 or 480 months. R is monthly rate, APR divided by 12 or 9 hundredths divided by 12 or 75 10,000ths. Plug these values into the needed deposit formula. We have 500,000 times 75 10,000ths divided by 1 plus 75 10,000ths to the power of 480 minus 1, that's equal to $106.81. Your employer needs to deposit $106.81 into your account each month. Assume the interest rate is constant over the period in question. Over a period of 40 years, interest rates can vary widely. Assume a constant APR of 6% for your retirement account. How much do you need your employer to deposit each month under this assumption? Here our R is different. It's going to be 6% annually, or 6% divided by 12, which is half a percent. Needed deposit is equal to half a million times 5,000 divided by 1 plus 5,000 to the power of 480 minus 1, and that's $251.07. Note that the decrease in the interest rate from 9% to 6% requires that the monthly deposit more than doubles. Nest egg, the balance of your retirement account at the time of retirement. Monthly yield, the amount you can withdraw from your retirement account each month. An annuity, an arrangement that withdraws both principal and interest from your nest egg. Annuity yield formula. Monthly annuity yield is equal to nest egg times R times 1 plus R to the power of T divided by 1 plus R to the power of T minus 1. In an annuity, you receive fixed payments every month. Example, suppose we have a nest egg of $800,000 with an APR of 6% compounded monthly. Find the monthly yield for a 20-year annuity. Here we have $800,000 in the account. We're going to withdraw equal payments every month for 20 years, and that's our 20-year annuity. Solution. R is APR divided by 12, or 6% divided by 12, which is half a percent. T is 20 times 12, 240 months. Monthly annuity yield is 800,000 times 5,000 times 1 plus 5,000 to the power of 240 divided by 1 plus 5,000 thousandths to the power of 240 minus 1 equals to 5,731.45. Right, so your monthly, so you will receive $5,731.45 per month. At the end of 20 years, you will have $0 in your account. Annuity yield goal. Here we have nest egg needed equals to annuity yield goal times 1 plus R to the power of T minus 1 divided by R times 1 plus R to the power of T. Notice it's the previous formula solved for nest egg. Suppose our retirement account pays 5% APR compounded monthly. What size nest egg do we need in order to retire with 20-year annuity that yields $4,000 per month? Solution. R is equal to APR divided by 12, or 5% divided by 12. T is 20 times 12, or 240 months. Plug in all the values into the nest egg needed formula. 4,000 times 1 plus 500 divided by 12 to the power of 240 minus 1 divided by 500 divided by 12 times 1 plus 500 divided by 12 to the power of 240. That's equal to $606,101.25.